Hello everyone. On this video we will be looking at vertical asymptotes. Okay, so starting off, let me give you the general definition. So what if we let f of x and g of x be continuous on an open interval containing C. Okay, so let's say if the function f at that particular point C does not equal 0, the function g at that point C does equal 0, and there exists an open interval containing C such that g of x does not equal 0 for the value x that is not the same as C. Then the graph of, let's say, h of x equals f of x over g of x as a vertical asymptote at x equals C. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our examples. Alright, so let's say for example, what if we want to find the vertical asymptote for, say, for problem A, f of x equals x squared plus 1 over x squared minus 1. And let's say for problem B, f of x equals cotangent of x. Okay, so for our vertical asymptote is basically saying where your denominator is equal to 0. So for A, f of x equals x squared plus 1 over x squared minus 1. This is basically telling us that our denominator can't equal 0, so that means x squared minus 1 can't equal 0. Alright, so since this is the difference of squares, this factors out to x minus 1 times x plus 1 can't equal 0, which means that x minus 1 can't equal 0, and x plus 1 can't equal 0. So in other words, x can't equal 1 or negative 1. So x can't equal 1 or negative 1. Okay, so these are your vertical asymptotes. All right, how about question B? For this, you just have to remember that cotangent of x is equal to cosine of x over sine of x. Okay, so that means f of x equals cotangent of x, which is equal to cosine of x over sine of x. Again, you'll find the vertical asymptote by finding what values will make the denominator equal 0. Okay, so we know that sine of x cannot equal 0. Okay, so what values make sine of x equal 0? We know that sine of 0 equals 0, sine of pi equals 0, sine of 2 pi equals 0, sine of 3 pi equals 0, and etc., and so on. Okay, so we can see here that basically we cannot let x equal any whole number, well, integer multiple of pi. Because remember also negative 3 pi is equal to 0, negative 2 pi, sine of negative pi, all of those are also 0. So in other words, x can't equal n pi, given that n is equal to an integer. Okay, so these would also be your vertical asymptotes. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so let's say, for example, we want to determine all the vertical asymptotes of f of x is equal to x squared plus 2x minus 8 over x squared minus 4. All right, so first thing you want to do for this one is factor the numerator and denominator. Factor the numerator and denominator. Okay, so you have x squared plus 2x minus 8 over x squared minus 4. Factored out, you have x plus 4, x minus 2. All over, you have a difference of square here, so that's x plus 2x minus 2. Okay, now you see here, those two cancel out. So we know here, x minus 2 and x minus 2 cancels out, so that gives us x over 4 over x over 2. Well, x plus 4 over x plus 2. Okay, So we see here that x equals -2 is the only asymptote, or vertical asymptote. Okay. Now you're probably asking yourself, okay, what about that x minus 2? How come that's not a vertical asymptote? And the reason being is x minus 2 equals 0, or x equals 2, is a removable discontinuity, not a vertical asymptote. All right. Okay. Oh, sorry about that. I thought I had it up far enough. Okay, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so let's say if you wanted to find the limit okay, let's say for problem A, you have the limit of x over 5x to the third as x approaches 0 from the right. And let's say for problem B, you have the limit of x over 5x to the third as x approaches 0. All right. So for problem A, you have the limit x over 5x to the third as x approaches 0 from the right. If you wanted to, you could go ahead and cancel out one of the x's and have it 1 over 5x squared. Doesn't matter in the final answer, but just if you wanted to simplify it a little bit. Okay, so you see here that we're approaching 0 from the right. So we're coming from this direction. So we're approaching 0 from the right, so we have our x. Now for f of x, since we're approaching 0 from the right, we'll have x equals 0, some value here. Okay, so what we'll do, we'll start at 2, 1, 0.01, and 0.001. Okay, so if we plug in x equals 2, you end up with 0.05. X equals 1, you end up with 0.2. Uh-oh. Plug in x equals 0.01, you end up with 2,000. If you plug in x equals 0.001, you end up with 200,000. Okay, so you can see here that your f of x is getting bigger and bigger and bigger. So if you plug in 0.0000001, you get a really big number. So we can see here that the limit of x over 5x to the third as x approaches 0 from the right is equal to infinity. Alright. Now, what about as x approaches 0? So you have the limit x over 5x to the third as x approaches 0. We pretty much do the same thing. But in this case, we're approaching from the left and right to make sure that they're equal. So we're going to go ahead approach from the left and right. Alright, so what we're going to do, since we already have from the right up there, we can just use that information. Alright, so I'll make this our x and make this our f of x. And we're going to approach 0. Okay, so we're approaching it from the right, so we already have it up here. So we have our 2, 1, 0.01, and I'll leave that 0.001, which was 0.05, 0.2, 2,000, and 200,000. Okay, so we have our limit approaching from the right. Now, look at approaching it from the left. So I'll just use -2, -1, -0.01, and -0.001. Basically just the negative of those if you're approaching it from that way. Okay, so here if you plug it in, it's 0.05, 0.2, 2,000, and 200,000. Okay, so whether you're approaching it from the left or the right, you get the same numbers that's getting bigger and bigger and bigger. So x approaches 0 from the left is infinity, and x approaching 0 from the right is also infinity. Alright, so that means since they're both the same from the left and right, the limit of x over 5x to the third as x approaches 0 is equal to infinity also. Same as to the right. Alright, so you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so let's say if we want to find the limit. Say for problem A, we want to find the limit of x minus 2 over x squared times x plus 4 as x approaches 0 from the right. And let's say for problem B, the limit of x minus 2 over x squared times x plus 4 as x approaches just plain old 0. Alright, so what I want you to do is go ahead and press pause and work on this one yourself. Okay, use the same steps as the previous example. Alright, Alright, so I'm going to assume you've pressed pause and you worked on this one yourself. So let's just verify your answer. Okay, so you have the limit as x approaches 0 from the right of x minus 2 over x squared times x plus 4. Alright, so just like before, we're going to go ahead and make our table. You have your x, and you have your f of x. Okay, so we're approaching 0 from the right. Just to pick any value at all, I'll pick 4, 3, 2, 1. Now, better yet, I'll just start at 3. Don't need that many. Let's say 3, 2, 1, 0.01, 0.001. That's good enough. Okay, so if you plug in x equals 3, you have 0.0158. Plug in x equals 2, you end up with 0. You plug in x equals 1, you have negative 0.2. You plug in x equals 0.01, you end up with negative 46.3. And if you plug in x equals 0.001, you end up with negative 499,625. So it made a pretty big jump. Okay, so we can see here that the values are getting smaller and smaller. Let me clean that up. There we go. So since they're getting smaller and smaller, you know the limit x plus 4 as x approaches 0 from the right is equal to negative infinity. Okay, now looking at problem B, the limit of x minus 2 over x squared times x plus 4 as x approaches 0. Again, just making up our table. Okay, well, this is our x. And we have our f of x. And we're approaching 0, so we'll approach it from the left and right. Okay, we already have it from the right, so we can just reuse those. 3, 2, 1. Oh, you can make that a little bit. That should be enough. 0.01, 0.001. Okay, we already have those. So we have negative 499,625, negative 46.3, negative 0.2, 0, 0.01, 58. There we go. Okay, now approaching it from the right, we'll say x equals negative 3, negative 2, negative 1, and we'll just jump right to negative 0.001. Again, you can pick different values if you like. This is just showing a little more detail in the pattern. Okay, so x equals negative 3, you have negative, and it's a whole bunch of 5s that just keep going over and over and over again. So I'll put that bar over to show that the 5's just repeat. Plug in x equals -2. You have -0.5. X equals -1 actually becomes -1. X equals -0.001 is -500,375, actually 0.1, and it keeps on going from there. Okay, so we see that approaching 0 from the left and the right both will give you negative infinity. So the limit x minus 2 over x squared times x plus 4 as x approaches 0 is also equal to negative infinity. Alright, so if you are still writing, feel free to press pause. We're going to go ahead and do one more example. Okay, so let's say, for example, you have the limit of 1 over x to the third minus 1 as x approaches 1, and find the limit. Okay, so you see here that your numerator is 1. We don't have to do anything there because the numerator is always going to be positive 1. Okay, so no matter what. Is always positive. Okay, so it's always going to be positive 1. Okay, so we can see here that for x equals 1.01, 1.001, 1.0001, etc. So in other words, approaching x from the right, the denominator is positive, but getting smaller. Okay, now if you want to verify that, just go ahead and plug in these values into your denominator on your x value, and you'll see that it's just getting smaller and smaller. Okay, now your denominator is getting smaller and smaller, but by that constant staying the same up top and your denominator getting smaller and smaller and smaller, your limit itself is actually getting bigger and bigger and bigger. So just because that's getting smaller, so you have a constant over a number that's getting smaller and smaller and smaller. That means the limit as x approaches 1 from the right of 1 over x to the third minus 1 is infinity. And again, to verify, you can just plug those in. Okay, so that means the value of f of x is getting bigger. When we approach one from the right. Alright, what about approaching 1 from the left? And again, if you wanted to, you can create a table and plug in the values. So we have x equals 0.9, 0.99, 0.999, etc. Okay. We can see there that if you plug in those values, the denominator will be negative, but getting smaller. Okay, now since your denominator is getting smaller and smaller and smaller, it's just basically becoming a smaller negative number. You have a positive divided by a really small number. That shows that the limit of 1 over x to the third minus 1, as x approaches 1 from the left, is going to equal negative infinity. So, since the limit from the left and the right are not equal, that shows that the limit 1 over x to the third minus 1 as x approaches 1 does not exist. Okay. Oh, and we also know that x cannot equal 1. Which really doesn't matter if the limit doesn't exist, but just a nice little note that sometimes they may want in your textbook. Alright. So, hopefully this made sense, and I will see you on the next video.